Hello everyone, my name is Vipra Joshi and I am an assistant professor in St. Andrews Institute of Technology and Management in Electrical Engineering Department. I am going to deliver a lecture on subject of Control System Engineering. In this video, we are going to discuss transfer function for the control system. This is Unit 1 topic of 6th semester in Electrical Engineering branch. Transfer function. Transfer function not only used for the control system, it is for any system. We can use transfer function. The transfer function is the ratio of Laplace transform of the output to the Laplace transform of the input. So generally in control system we are going to prefer Laplace transform. So the equation of Laplace transform is equivalent to Laplace transform of output upon Laplace transform to the input. Here Gs is the Laplace transform of the gain and Ys is the Laplace transform of the output and Us is the Laplace transform of the input. So we can define the transfer function equal to Laplace transform of the output upon Laplace transform of the input. So here for example, I am having a control system like this. Here Xs is the input transform of input signal. Here is xt is the input of the signal and xs is the Laplace transform of the input and ys is the output of the signal. Okay, and the output signal is yt. Here this is summing point. If we define the summing point, thus this symbol used to represent the summing point. By the summing point, we can either add the signal together and subtract the signal together. If we use this symbol, we can add the two signal, and if we use this symbol, we can subtract the signal. So here Hs is the feedback element gain, and so everything I consider in terms of frequency domain. You can see that here input signal, output signal, gain, and this is transfer function for forward path, and Z is the error signal. So all these signals are we consider in frequency domain. So here in this case the system, this is negative feedback system. We can say here this is negative feedback system. Okay, then so in this case we want to transfer function and we need to get by using the ratio of output ys upon input xs. So how we can get ys upon xs? Before getting ys upon xs, I want to get the value here. What is error signal? So here you can see ZS equal to XS minus ZS into YS HS is the feedback element and YS is the output. As we know that in the closed loop system, a part of output is feedback to the input. So here these two signals are multiplied. And so in this here the value of ZS equal to XS minus HS into YS at this point. Here XS signal and the feedback signal HS is multiplied at this point of output. Now if we want to write the equation for the output at present point, we can see that here the YS means the output YS equal to GS into ZS, because here the signal is coming to the multiply signal of ZS into GS because some error signal is introduced here. So we can say YS equal to GS into ZS. Now if we put this in equation, means if we put the value of ZS in first equation, we can get YS equal to GS bracket open XS minus GS into YS. Move all the terms with YS to the left hand side and keep the terms XS on the right hand side. We can get YS plus GS into HS into YS equal to GS into XS. If we take common from here YS, the equation become YS into 1 plus GS into HS equal to GS into XS. And we can say that YS upon XS equal to GS upon 1 plus GS into HS. This is our transfer function. So, at the ratio of output to the input. Here YS is the output and XS is the input. So we can say the Laplace transform of output upon Laplace transform of input is called the transfer function, like this. So like this we can get same for positive feedback signal. So here the transfer function is nothing but it is the ratio of Laplace transform of output to the Laplace transform of input. Now, what is positive feedback and negative feedback? There are two types of feedback. One is positive feedback and negative feedback. Positive feedback. The positive feedback adds the reference input. Okay, we can say, as we know that in control system, the closed loop of system, if we saw any path from output to input, from output to input. So if we see any path from output to input, we can say there is feedback and we have having feedback. Then how we can ensure that this is positive or negative feedback. If you are subtracting your feedback from input, this is called negative feedback. And if you are adding your feedback from input, we can say it is a positive feedback. So here we add the feedback path to the input. So we can say this is positive feedback signal. If we calculate the positive feedback signal, we know that here CS is the output for the control system. So we can say CS equal to G into RS. So we know that at this point we calculate here, as we calculate from a previous slide, here the signal is RS plus CS into H into gain. Okay. So if we calculate this value, if we put here CS equal to RS plus CS into feedback into gain G, and we take common CS bracket 1 minus GH equal to G into RS, and we can say here CS upon RS equal to G over 1 minus GH. G is the gain and H is the feedback signal. So by this, the transfer function is equal to G upon 1 minus GH. Here T is the transfer function, or we can say the overall gain for positive feedback control system, and G is the open loop gain and H is the gain of feedback path. So same for we can calculate the negative feedback signal. What is negative feedback signal? As we know that if we subtract your feedback from input, so here if we derive same equation, then the transfer function equation will come T equal to G upon 1 plus GH. So these are positive and negative feedback signal. Now effect on feedback. First is sensitivity. We know that sensitivity is equal to change in percentage change in transfer function upon percentage change in gain. So we can define it del T over T upon del G over G. G is the gain and T is the transfer function, and we know that our transfer function equal to G over 1 plus GH. So after solving it, we can get sensitivity equal to del T over del G into G over T. So we need to define here what is the value of del T over del G. By differentiating this equation, we can get, if we denoted the part u over v. We know that by differentiation formula, v into du over dt minus u into dv over dt upon v square. So we use. So how we will differentiate it? We can say that it is represented by u upon v. So as we know that here is v 1 plus gs into differentiation of u. We know that u is g, but here we differentiate it with respect to g. So the differentiation g with respect to g is 1 and minus u is g and differentiate v. So the differentiation 1 plus gh with respect to g. So here is 1 is the constant term, so 0 plus g into h. We differentiate with respect to g, so here the term is h will come. So we can say here g into 0 plus h, and we know that in denominator v square. So here 1 plus gh square. Okay, it means here if we calculate these terms, we can get dt over dg equal to 1 over 1 plus gh square. So if we combine equation 1 and equation 2, we can get, if we put here the value of g over t, this terms is come 1 over 1 plus gs. So sensitivity define equal to 1 over 1 plus gs, and we can say that it depend upon the gh value. If gh value is positive, then this terms is 1 plus gs is going to increase. So the total value of sensitivity is going to decrease. If there is decreasing in feedback path, so 1 plus gs value is decreasing, and we can say the sensitivity is increasing. So by this we can relate sensitivity with respect to gain and feedback system. Now the second is stability. As you say, your system is more stable, and whenever output is more controllable. So whenever the output is in your control, we can say that it is a more stable system. So we know that here t equal to g upon 1 plus gh, and if we say that our feedback system g is h equal to minus 1 over g, and here the terms come 1 minus 1 and it become 0. So if we say the value of gh equal to minus 1, so 0 will become in denominator, and we can say g over 0 equal to finite. it means your output is not going to in your control because t is infinity. That's why you need to take care about means for the stability. Next term is gain. We know that t equal to g over 1 plus gh, and we can see that if here feedback signal is increasing means positive, then 1 plus gs terms is also positive, and we can say that our gain is decreasing. If here h is negative feedbacks, and we know that here 1 plus gs is negative, and we can say that our transfer function is increasing. So we use in control system the negative feedback control. Now the last term is external disturbance or noise. We know that there is thermal noise in electronic circuit and commutator or brush noise in motors. If we say the system, here R is input, G1 is the gain, and some noise is introduced here, and G2 is the gain of second path, and C is the output and H is the feedback. So if we calculate C over R, we know that here G1 into G2 into N is the noise term, and it is for the open loop system if here H equal to 0, and for the closed loop system if there is a feedback path, then we know that C over R, our transfer function will be G1 into G2 upon 1 plus G1 G2 into H into N. And if we take the ratio of C over N, these terms will come in for the open loop system, C over N equal to G2, and for the closed loop system, C over N equal to G2 over 1 plus. We can say that in closed loop system, our output to input means output to noise ratio will be decreases because 1 plus G1 G2 into S terms will be reduce the output to noise ratio. So we used closed loop system. I hope you have understood this topic.